So first we're going to explain Newton's first law. So basically the principle of Newton's first law is that anything in motion stays in motion until an outside force acts upon it. And anything at rest stays at rest unless an outside force acts upon it. So for example, here we have a bowling ball and some pins. Until the person releases the bowling ball will be stationary. And after the release, the bowling ball will keep moving until the pins, the outside force, stop it from moving. And now we're going to go over Newton's third law. So in Newton's third law, it says that every action has an equal and opposite reaction. So for example, we have two people pushing on each other. So each person feels the same amount of force in opposite directions. So that's the action and the opposite reaction. So now we're going to go on to Newton's most important law, the second law, which basically states that F is equal to ma. This is the biggest identity, and we can use that to help us solve a variety of problems. For example, we have a mass on an inclined plane. The first part is we want to find the acceleration of the block. So we can use our identity, the sum of forces equals ma. So now we know the only force on the block down the incline is the force of gravity in the x direction. So we have mg sine theta equals ma, and you can easily solve that to find the acceleration. And now for the second part, we use a kinematic equation to find the speed of the block at the bottom of the incline. So again, we couldn't have done that without this fundamental identity, F is equal to ma. And we see again that identity resurfaces when we have to find the force on this block required to keep it stable. So in the x direction, we have two forces: the force of this rope and the force in the x direction of this diagonal rope here. So if we make the sum of forces equal to 0, because the object is not accelerating, and therefore ma is equal to 0, so F is equal to 0. We can solve for the force of the ropes, and we can do the same thing in the y direction in order to solve for the force of tension on each rope required to keep the object stable.